Hello everyone, this is a presentation on new technology for drying wood using quicklime by myself Mohammed Darwish, co-authored with Rami Azir, Azmi Azmi, Abdulrahman Higazi, Sharif Al-Lisi, Ahmad Morsi, Khaled Nassar and Hassan Yusuf. So first, it's well known that currently used wood drying technologies are all energy consuming, expensive, and most of them are time consuming. The current study involves a new method of drying wood which is fast, zero energy consumption, more economic, and scalable. The method involves dehumidification of wood using a drying agent. The drying agent chosen was quicklime, calcium oxide, as it is cheap, readily available in large quantities, and could be reused or resold as hydrated lime. The wood used within the study was Casuarina glauca or the she oak wood, as this was farmed on wastewater and available in its green state. So the methodology, first some preparatory steps are done. The Casuarina glauca tree was cut down. The lumber was sawed into equal sized planks for testing. Simultaneously, the quicklime was bought and crushed. Two 1 meter by 0.5 meters by 0.5 meters pits were dug. The pits were covered from all sides with insulating sheets so that seepage does not affect the moisture as shown here, and the wood was buried in the quicklime. This process was done several times. So the first two set of pits were done having no lime replaced during the time of the experiment. So first the initial water content was measured before burying. Then, within one pit, one plank of wood was buried and surrounded with quicklime. Within the second pit, four planks were buried together. And three readings were taken from each pit plank, from its top, bottom, and middle, every 2 days. And this process continues for 10 days. So, the same, and again, appearance grading was assessed at the end of the experiment. Appearance grading was done according to the European standards. However, the second set of the samples were the same experiment was done, however, with a very simple exception, which is that the lime was replaced after 5 days from the beginning. So, at the middle of the experiment took 10 days. So, at the middle of the experiment, the lime was replaced with a new quick lime. And you will see the effect is noticeable. And also, the same process was repeated. I mean, the same process of measuring the moisture of lime of the wood was done using the same apparatus. So the results were for experiment one, which had no lime replacement. When you look at the single plank versus four planks per pit, the difference between the two sets of curves was not large. I mean, in both sides, whether the left-hand side or right-hand side, you could see that the measurement didn't have a noticeable difference. I mean, the moisture played around the 20% at the 10th day, whether for the single plank or the four planks. So this is more or less the same. Okay. However, comparing this to replacing the lime after 5 days, there is a major difference here when it comes to the moisture at the 10th day. I mean, after replacing the lime, as if the new lime is able to absorb more humidity from the wooden planks, and achieved a lower moisture content within the wood. So here the moisture content, instead of being 20% on the 10th day, it became maybe around 15%. So this is even more apparent when comparing the data. I mean, raw wood, the control, it was 40%. The experiments within having no lime replacement, an experiment called experiment 1, it played between 17 and 19%. However, the ones with lime replacement are mainly significantly less, playing between 13 and 14% of moisture. So let's move on to the grading. I mean, what's the effect of having lime on the grading, and what's the effect of replacing the lime on the 5th day on the grading? So what we are doing here is what we call appearance grading, because we didn't have access to the labs due to the COVID-19. So appearance grading was performed according to the European standards. So the first character is Q, which stands for oak. The second character is, it could be B, S, F, or P, depending on the type of the product. In our case, it's a P because it is beams. And actually, P stands for planks. So, however, but I mean, planks or beams, it's the same thing. Then the last depends on the quality of the grade. So the last one, if it's an exceptional quality, it's an A. In decreasing order, it's 1 to 1, 2, 3, 4. If it is something of very poor thing, I mean something of major defects, you'll have an X or 2 X's. So only features distributed across the entire piece are considered, except for dead knots, the maximum number of which is determined per linear meter. According to the European standards for grading, the beams we had in this experiment were ranging between QPA and QP2. So for raw wood, it was apparent that it was QPA. However, within experiment 1, within one plank of wood in one pit, it was found that we had some cracks, some significant cracking that caused us to say it was a QP2. For the 4 planks of wood in one pit, again within experiment 1, and again I'm saying within experiment 1, which means having no lime being replaced. So again, this is QP2. So having no lime being replaced within the experiment, this caused having a QP2 grade. Replacing the lime on the 5th day, it had enhanced the classification a little bit. So instead of having it as a QP2, now the degree of cracking was not as significant as before, and it was QP1. This is applicable whether it's 1 plank of wood in one or 4 planks of wood in one pit. Okay, so here the degrees of the cracks are not as severe as the case when you are not having lime replaced. So it seems that lime being replaced did not only improve the moisture content, it also improved the quality of the end product that we are having. So in conclusion, we could say that quicklime drying method was efficient, and the amount of quicklime used was sufficient enough to reduce the moisture content of the wooden beams. Changing the wood to quicklime ratio did not significantly affect the rate of drying. Replacing the quicklime after half of the duration of the experiment, which is 5 days, on the 5th day, yielded excellent improvements with a lower final moisture content, a faster rate of decrease of the moisture content, and a better appearance grade of QP1 according to the European standards. The quicklime method at hand required extremely less time than the air drying method, a slightly higher cost, and resulted when compared to the air drying method for sure. However, it resulted in wood with a worse grade quality of wood by 1 grade, but still acceptable further than lower final moisture content. And again, all of that is when comparing it to the air drying. However, it's of course non-comparable to the vacuum drying for sure, or whatever other drying energy consuming drying method, which is energy consuming and cost consuming. So, I mean, here you are comparing it to something that is comparable to it, which is the air drying. But again, air drying could take months. So I mean, you are losing the time, which again translates to money. So again, we as mentioned, when comparing it to kiln drying, it has significantly lower cost and energy consumption and the carbon footprint, and for sure it has a better quality product in general and a lower final moisture content. It is recommended to have different wood to lime ratios being studied, and it's also recommended to study replacing quicklime every 2 or 3 days, and it's highly recommended to repeat the experiment for different types of wood and repeat it on larger scales. And of course, an economic study is worth to be performed to confirm economic viability of the technique. We'd like to acknowledge the support of the American University in Cairo, whether in terms of staff or laboratory crew. Thank you.